Howdy, I am Tom Christiansen of Neurochrome, and this is a Hitachi SR-5200 stereo FM receiver. And it belongs to a friend of mine. He likes to keep these older receivers around and going, and it has a couple of really annoying issues, the most prominent one being that it tends to drop the left channel, and that's pretty annoying. The other thing I've noticed with this thing is that when I use it for FM radio, it seems like the channel imbalance is, or the channel balance is out of order. So there's way more sound coming from the right speaker than from the left, even though both speakers are going. So let's dig into that and see if we can fix that. To take this thing apart, first, of course, power it off and make sure that it is unplugged. And then you remove the 4 or 5 screws from the bottom, and then this whole assembly just slides out like that. And this is what it looks like on the inside. We have here a preamplifier board. This board here is the FM and AM tuner. And then this board here is the power amplifier with the power supply for the entire receiver here, powered by this power transformer. When I listen to this and it drops the left channel, that happens on all the inputs, so phono, auxiliary, FM, and so on. And that means that the error or the failure is something that is in common to all of those. So that immediately points me to the preamplifier. So what I then did was I wiggled the tone controls, and that did nothing aside from changing the bass and treble levels. Balance control works as expected. The volume control works as expected as well. If anything, the volume control has pretty high channel imbalance, which indicates that the potentiometer is a bit worn, potentially, or maybe it's just not that great of a pot to begin with. But cleaning the pots did nothing, so it must be something that's common to the circuit between all the inputs and the preamplifier. So here's the schematic for the preamplifier. This is the preamp itself. And we have some tone control here, looks like a classic Baxendal tone control. The phono stage is this guy here, phono input here, and then the various other inputs are here. So what they have in common is that the signal is routed through these tape monitor switches. So I started playing with the tape 1 and tape 2 switches, just sort of exercising them a little bit. And usually these switches are silver plated and they will actually self-clean a little bit. But of course only to a point. So what I found was that the tape 2 switch was basically beyond repair. You can probably find a switch for these. It looks like it's a custom version of a switch that's still in current production, but the custom version has longer pins and it would be a pain to switch it out. So what I chose to do was to just bypass the switch. The owner of this will be using the auxiliary input for the most part with actually a Bluetooth dongle, ironically enough, or on the FM radio. So that'll work just fine. And if we have a peek at the schematic again, you'll see that the tape 2 switch here, if I bypass this so that it is connected in what's shown here is the off position, then if somebody accidentally pushes it to on, all that really happens is the tape 2 gets connected through these 56 kilo ohm resistors, and that's not going to do any damage. It's not going to give the expected behavior, but at least nothing is going to blow up. So that seems like a fair trade-off between, ease of repair and time spent repairing and what the owner of this thing actually wants. With the switch bypassed, the receiver now works well. It no longer drops the left channel, so that issue seems to be fixed. Cool. What I've noticed though, poking around in this receiver, is that nobody has changed any of the capacitors. And that's fine. I'm actually a fan of if it ain't broken, don't fix it. But these capacitors are getting pretty old. They are probably like 50 plus years old at this point. So I would at least swap the 2 output capacitors here, because if they fail, they take your speakers along with them. And that's no fun. So it's pretty cheap. They're like $1 each, something like that. So that's pretty cheap insurance. The other thing I've noticed is that the power supply capacitor here has this really nasty bulge. I'm not sure what's going on with that. Maybe it's just nothing. But it doesn't cost much to change the capacitor now. And also, I'm not really sure if these old capacitors have a safety vent. So that means that if the capacitor fails, it could actually explode, and that could do some real damage. So let's just swap it out to be on the safe side. But before I tear into this, let's just get a quick measurement of the ripple voltage on the power supply. So I'll get my oscilloscope going. And while that's booting up, I will connect the ground lead to the ground point here. Conveniently, the points are marked, so that's nice. And let's turn the receiver on. And of course, now I have to be a bit careful where I poke my fingers here. And let's look at the power supply voltage. So that looks like this. And I have the oscilloscope AC coupled and triggering on the AC line voltage. And as you can see, there's about 500 or so millivolt peak to peak of ripple on the power supply. And that's actually not bad, but then it does this weird stuff where it just starts bouncing around, and it's just, I don't know. So I think I'll go ahead and replace the capacitors, and we'll take a measurement after. It really should go without saying, but I'll say it anyway. When you start tearing into the receiver, make sure that you have it unplugged. And also make sure that you give it some time for the capacitors to discharge. In fact, I recommend that you measure the voltage across the supply cap or any other capacitor that you swap out before you start soldering on them, because otherwise you could be in for a pretty nasty surprise. The other thing to be aware of is that these boards are single-sided, and also they're pretty old. So that means that you want to be a little bit careful with the heat. So stay like below 380 degrees C or so. So 700 degrees Fahrenheit is about appropriate for the soldering temperature. And be a little bit careful that you don't put too much pressure and otherwise sort of rough up the circuit board, because the adhesive that holds the traces to the board is not the greatest usually. So you can actually lift traces off the board, and then you just have a bigger mess to deal with. So anyway, let's get started here. So the capacitor I want to swap out is the C04. And as you can see, it has 4 pins. So it's a bit of an unusual capacitor footprint, but I'll use my trusty solder sucker and a relatively wide, about 1/8 of an inch or 3 millimeters wide tip on the soldering iron. And let's just get going here. So as you can see, it's a little bit of a trick to get all of the solder flowing here, but after a couple of pumps with the desoldering pump, it usually clears off the solder. And let's do the other joints here. Ta-da! And now this capacitor should be removable. Ta-da! And so that's interesting. There's a little bit of a sort of a burn mark on the bottom of it, and it doesn't look like it has a vent. Kind of interesting to find out. I think I'll take the cap off here and see what's underneath. Oh, that is interesting. So, yep, there is no vent on this, no safety vent. So if this was to fail in a way that causes the electrolyte inside to boil, then this turns into a hand grenade. So that's no cool. So it's a good thing we get that swapped out. So of course, I mean, this is clearly marked with 2200 microfarad, 63 volts, so that's easy. And you will find that the modern parts are a lot smaller. So I actually chose to up this to 4700 microfarad. You don't want to go too crazy on it, because if you increase the supply capacitance, you also increase the peak current through the rectifier diodes. I checked the datasheet for the diodes. They're good to 40 amps peak. So I feel good about just doubling the capacitance. Next challenge will be to find a capacitor with the correct pin spacing, and you're not going to find this particular footprint. It doesn't exist anymore. So what I did was I took advantage of this hole here, and I found a capacitor that will connect with one pin on the plus here, and then with the minus pin sticking through the hole, and I think I can make that work. So here's the replacement capacitor. It is 4700 microfarad, 63 volts, versus 2200 microfarad, 63 volts, and about 50-year difference. So it's pretty impressive, actually, with the, I mean, this is what, quarter of the volume, something like that. So that's pretty cool. And they might look identical, but I bet this one is scored in the aluminum can underneath, so that if this needs to vent, it'll vent safely by blowing up this plastic disc and then spilling its guts instead of turning into a bomb. So that's cool. It is a snap-in type, but it's not going to snap in with the holes that we have in this circuit board. But I'll just make sure that it actually fits before I start messing with it. And it drops in quite nicely. So now I'll get a bead of hot glue going. I'm usually not a fan of hot glue. It tends to be pretty messy, but I don't see another way of making this capacitor stick in the board. And then, before the glue hardens, I'll stick the capacitor into the board. Oh, come on, there we go. And now I just need to wait for that glue to cool. But we're not quite done here. We also needed to swap these output capacitors here. They are 470 microfarad, 63 volts, and I was able to find a modern equivalent that's about half the size, but has the correct pin spacing. So that's cool. These should drop right in, and I'll just desolder these capacitors and solder these in instead. The output capacitors were pretty easy to replace. The replacement dropped straight in, soldered in, life's good. So now for the fun part, and that is the power supply capacitor. As you can see here, its pins poke through here, and this one is the plus pin. That one is easy. I can just solder that one and be done. But the minus pin here needs to connect over here. And I will do that with a piece of solid wire that I'll just wrap around this pin here and solder to this pad. And that, along with the hot glue that holds the capacitor in place, should be good enough. And now for the minus pin. So I'll take some solid core wire, I'll make a loop in one end after I stripped it, of course, and I'll wrap the loop around the minus pin of the capacitor, so like so, and then just crimp it with the pliers. I need to go over there. So snip the wire to length, like so, and somehow miraculously it stayed put. Cool. So now all I have to do is solder. And there you have it. So now all I have left to do is to turn this over and see if it still works. So let's power this thing up. No explosions, life is good. Let's measure the ripple voltage. So this didn't really seem to change a whole heck of a lot. But, you know, I mean, for the couple of dollars a capacitor costs, I think it's a good idea to swap them out. The original cap actually measured 2500 microfarad, so it was probably still good, which is actually kind of remarkable given the age of this thing. But, you know, I'll sleep better at night knowing that the capacitor is not suddenly going to turn itself into a hand grenade. So, you know, life's good. Now, what I would like to do is to verify the bias of the output stage, because I have noticed that it's drifted a bit. And I'll do that by hooking up a voltmeter to the two test points on the output stage of each channel. The test points for the bias of the output stage are conveniently accessible right here on these pins, and as you can see, I have my voltmeters hooked up to them. They're supposed to measure 20 millivolts plus minus 2.5 millivolts, and as you can see, they're running a little bit low. What I have also noticed is that the bias pots, these two here, are really quite grimy. So what I'll do is I will turn them to minimum bias, and I'll clean them up with some contact cleaner and give them some fader lube, which is lubrication for trim pots and potentiometers, and then I'll adjust the bias. I'll just mop up the excess with a rag here. Like that. And then we'll just wait for this to dry, and then I'll ready to power it back up. Make sure that you keep the power off and the equipment unplugged while you use the cleaning sprays. And once the residue has dried off, let's power it back up, and I'll adjust the bias for roughly 15 to 20 millivolts. I'll then wait a while. I'll keep an eye on it for about an hour until the heatsink has had a chance to stabilize thermally, and then I'll adjust the bias for 20 millivolts on each channel, and then that part will be done. It's been, about like an hour and a half, give or take, and I have checked up on the amp periodically, like every 15 minutes or so. And whenever I've checked up on it, I've adjusted the bias to 20 millivolts, and it still sits rock solid at 20 millivolts plus minus 2.5 millivolt like it's supposed to. So this is good. I will call this good. So the next up are the issues around the FM tuner, where there might be a channel imbalance, and also I've noticed that the needle here, the indicator, is about 2 megahertz off, so I'll fix that as well. So finally, I have an excuse to use this RF signal generator that I picked up at an employee auction years ago, before I went out on my own. I think I paid an entire $10 for it. So anyway, it provides 100 megahertz with a modulation frequency of 1 kilohertz. So when I plug this into the antenna input of the FM receiver here and tune it to 100 megahertz, I get 1 kilohertz in the headphones. The channel balance seems pretty good. As you can see here, I have the output of the tuner hooked up to my AC voltmeters, and they both read about 20 millivolts at the audio output of the FM tuner. And I did the math, they're off by about 0.2, 0.25 dB. That's really not enough to worry about. So I'm, as I said, a believer of if it ain't broke, don't fix it. So I'm not gonna try and tweak that in. The channel imbalance on the volume pot is actually a lot worse. In some spots, it's off by like 5 dB, and in most cases, it's off by like 0.1, 0.2. So not enough to worry about. So all I have left now is adjust the tuning meter, and then move the needle by about 2 megahertz, because I have it tuned to 100 megahertz and it actually reads like 101.5, give or take. So I bet what happened with that is that at some point somebody replaced the bulb that lights up the needle here. In doing that, they have to undo the line here. In doing so, they accidentally moved the needle. So I'm just gonna move it back. Maybe with a pair of tweezers. There's one, and there's two, and now hopefully I can move the needle here a little bit. I'll just hold the tuning capacitor steady, and let's see if I can slide the needle. Oh, there we go. So 100 megahertz. I just want to make sure that I'm still centered on the carrier frequency. There you go. Now I just gently need to put that line back on. Maybe you noticed a moment ago that when I had the tuner centered on the carrier frequency, the tuning meter was off slightly to the left. And in order to adjust that, I need to adjust the top core in this transformer right here. That's part of the FM discriminator. I don't have the tools for that. So this is going to be one of those where if it ain't broken, and it's really not all that broken, don't fix it. In general, with all these transformers and inductors and whatnot, if you don't have the proper tools to adjust them and the proper equipment to perform the adjustment, don't mess with them. Because if you knock the tuner out of alignment, it's really difficult to get it back in alignment, especially without the right tools. So I'm going to call this good. It is as good as it's going to get, and put the chassis back on and try it out. Thank you very much for watching. I really appreciate it, and thanks for sticking with me so far. I know that my videos tend to be a bit on the long side. If you have any comments or suggestions for improvements in these videos, topics you'd like me to cover, for example, drop them in the comments below, and click like and subscribe and all that good stuff. So thanks again for watching, and have a great day.